Welcome to this National Industrial Conference presentation. Today, we are diving into a critical board-level discussion that often goes unspoken: how aggressive production targets can silently erode the very foundations of our enterprise value. I am Santosh Raikar, and over the next hour, we will explore the delicate balance between protecting today's output and preserving tomorrow's asset capability. We start with a fundamental question every board member should be asking. Are our production targets actually improving our performance, or are they consuming the asset base that generates our future revenue? It is a sobering reality that a target can be mathematically achieved on a spreadsheet while the reliability and health of the machinery deteriorate invisibly beneath the surface. My thesis for this session is simple yet urgent. While production targets are essential for execution, unmanaged pressure is dangerous. When these targets dominate our culture, teams often trade long-term asset health for short-term schedule attainment. This damage isn't loud. It manifests as deferred work, normalized abnormalities, and hidden defects. The solution isn't to lower our ambitions, but to adopt risk-adjusted leadership that balances output with long-term enterprise value. Our agenda today will take us through why this matters to industrial management, the mechanical and behavioral ways target pressure damages assets, and the financial consequences of this hidden consumption. We will then look at the KPI conflicts that create these problems and conclude with a roadmap for a management system that protects reliability. We begin part one by looking at why this issue is so central to corporate governance. Ultimately, production targets only create true value when the asset system remains capable of repeating that performance month after month. To be clear, production targets are not the enemy. They are vital for translating strategy into action, creating focus and accountability. The problem only arises when the target becomes disconnected from the actual condition of the assets. A mature system must measure not just what was produced, but what level of asset risk was accepted to get there. We often see a silent trade-off occur. A team might hit this month's numbers by running through alarms or delaying critical repairs. The financial report looks excellent in the short term, but the asset system is quietly accumulating risk and future downtime. This is the hidden cost of target-only management. This chart illustrates a dangerous pattern: production targets being met while the asset health index steadily declines. The real risk isn't low output, it's high output achieved by consuming hidden capability. As leaders, we must watch for this divergence. This is where reliability transforms from a technical issue into an enterprise risk conversation. There is often a gap between what the board sees and what the asset experiences. While the board sees schedule attainment and controlled costs, the asset system may be feeling compressed maintenance windows and increased forced outage probability. We need to bridge this information gap to understand the true state of our operations. It is crucial to understand that this is not just a maintenance issue. Asset health determines the repeatability of our entire performance, because production, engineering, and finance all shape the decisions that impact our equipment. Target pressure is a governance issue that requires a cross-functional solution. In part two, we will examine the specific mechanisms, mechanical, behavioral, and organizational, through which target pressure damages asset health. Think of asset health as stored production capability. It is built through precision maintenance and operating discipline, but it is consumed through overload and deferral. While you can borrow against this health for a short period to hit a deadline, you cannot borrow against it forever without catastrophic failure. This feedback loop shows how the cycle becomes self-reinforcing. Aggressive targets lead to running harder, which leads to maintenance deferrals and declining health. This eventually causes unplanned downtime, which then creates even more pressure to make up for lost time in the next period. It's a spiral that looks productive, right, until the moment it breaks. Target pressure also changes human behavior. Teams may become reluctant to report defects that could jeopardize the day's numbers. Maintenance might shift into a patch and release mode, and operators might learn to tolerate abnormal conditions, effectively training the organization to ignore the warning signs of failure. Mechanically, this pressure manifests as running equipment outside its intended envelope, higher speeds, temperatures, or loads than designed. It leads to shortened maintenance windows that increase the chance of error and frequent start-stop cycles that place immense thermal and mechanical stress on the system. We often see a maintenance window squeeze. To hit a target, planned maintenance is delayed or shortened. While this avoids downtime this week, the asset will eventually take its own window through an unplanned outage. The irony is that the downtime we avoid today usually returns later with significant interest. Deferred work does not grow linearly like a simple checklist. It grows like risk. A backlog isn't just work waiting to be done. It's risk waiting to be realized. As this chart shows, the forced outage exposure escalates rapidly the longer we defer corrective work. Leadership must require explicit risk acceptance for these decisions. One of the most insidious effects is when abnormal becomes normal. Repeated workarounds train the staff to accept process variations and alarm floods as just how it runs. The organization loses its sensitivity to early failure signals, which is often the precursor to a major incident. We must also consider the start-stop penalty. Aggressive daily targets often lead to frequent interruptions and grade changes. Many industrial assets are designed for stable, continuous operation. Constant recovery from instability stresses every component from motors to process chemistry. We should be quantifying this exposure, not just counting downtime minutes. Finally, human fatigue becomes asset risk. Target pressure drives overtime and rushed restarts, increasing the probability of wrong decisions and maintenance-induced errors. A fatigued organization might keep producing today, but it is actively creating tomorrow's failure. Asset health is inextricably linked to human system health. Moving to part 3, we will discuss the financial and risk consequences. It's important to recognize that short-term target performance can often mask a significant leakage of long-term enterprise value. We must distinguish between production volume and enterprise value. Maximum production doesn't equal maximum value if it accelerates capital demand or creates safety exposure. The real question for leadership is, what did it cost the asset system to hit that target? Target-only behavior creates layers of hidden costs, from scrap and rework to energy loss and emergency repairs. The immediate gain from pushing production is often dwarfed by the downstream costs of instability. True financial analysis must include these avoided future losses to protect the bottom line. Risk often accumulates beneath stable production reports. An improving output trend can hide rising residual risk. This is why boards need visibility into asset health and deferred work alongside their standard KPIs. A system is only healthy if its performance is repeatable and sustainable. Beware of the EBITDA trap. Deferring maintenance can make this month's expenses look better, but it's essentially borrowing from the future at a high interest rate. Real productivity isn't cutting costs by increasing risk. It's achieving results through reliable asset performance. Target pressure also accelerates capital demand. Assets operated in abnormal conditions age faster, and deferred defects lead to greater collateral damage. Often, a plant asks for replacement capital not because the equipment was faulty, but because the operating system consumed its life prematurely. Quality drift is frequently an early asset health signal. Before mechanical failure occurs, you'll often see increased variation or customer complaints. When targets dominate, teams may adjust the process to hide the symptom rather than fixing the asset. We must treat quality losses as a trigger for condition reviews. In part 4, we examine the organizational causes. Often, the root of the problem isn't the people, but the way targets, incentives, and decision rights are designed. KPIs often have unintended consequences. For example, a focus on daily output might reward running through defects, while a focus on maintenance cost might reward delaying repairs until a total failure. We need board-level controls that pair these metrics with asset risk and deferral tracking to ensure a balanced approach. We frequently see local targets fighting the overall system. Operations is rewarded for output, maintenance for cost, and finance for current period performance. This lack of alignment means no one is looking at the total risk being accepted by the enterprise. This is a fundamental system design problem. Decision rights are often dangerously unclear in high-pressure environments. Who is actually authorized to run through a known defect or cancel a maintenance window? Without clear accountability for risk, the The loudest pressure, usually for immediate output, wins by default. Many industrial organizations have a hero culture that celebrates emergency recovery. While the team that saves the day after a crash gets the glory, the team that quietly prevents the crash goes unnoticed. If we don't align recognition with prevention, we will always be stuck in firefighting mode. The "we will catch up later" illusion is common, but later rarely comes with more resources or less pressure. Deferring work shouldn't be a vague promise. It needs a designated risk owner, a firm due date, and a clear trigger for escalation if that date is missed. Finally, poor data turns professional pressure into office politics. Without strong asset health data, decisions become battles of opinion. Good data doesn't make hard decisions disappear, but makes the trade-offs visible and allows for objective risk management. Part 5 focuses on better metrics and governance. A truly effective production system should reward repeatable value, not the temporary extraction of asset life. We need to move toward a healthier leadership question. Instead of just asking, did we hit the target? We should ask, did we hit it while maintaining our asset health and future capability? This doesn't weaken accountability. It makes it comprehensive. A balanced performance dashboard is essential. It should include leading indicators like defect closure and maintenance window compliance alongside production numbers. This provides the necessary context to ensure we aren't accidentally consuming our assets for short-term gains. What are these leading indicators? They include things like critical corrective work completed on time, condition monitoring exceptions closed before failure, and tracking start-stop cycles. These metrics provide a real-time health check on the systems that drive our production. Production planning must be risk-adjusted. We should discuss known asset constraints before the plan is frozen, not after a failure occurs. Documenting high-risk deferrals with clear ownership makes production planning a tool for asset protection. We must protect maintenance windows with the same discipline we apply to production commitments. A maintenance window isn't idle time, it's an investment. If the asset never receives planned care, it will eventually choose its own time to stop, and it will be at the most inconvenient moment possible. This table outlines a clear decision right model. It defines who owns a decision, like running with a defect, and who must be consulted. Most importantly, it identifies the escalation triggers that ensure high-risk situations are handled by the appropriate level of leadership. Finance has a critical role to play here. Rather than just challenging maintenance spend, finance should help quantify the value of avoided losses and the cost of asset risk. This moves reliability from a cost discussion to a value protection discussion that the whole executive team can support. For boards and senior executives, the mandate is clear. Ask for production and asset health data together. Ensure visibility of residual risks and protect the governance system that balances output with safety and reliability. Never reward performance achieved through silent risk accumulation. In Part 6, we look at the operating model and a roadmap for implementation. The goal is to build a single production system that preserves both health and value. Success requires one plan. Production, maintenance, and engineering must share a single view of constraints and risks. The production plan should explicitly state its asset health assumptions, and the maintenance plan should highlight the value it is protecting. Our daily operating rhythm must change to include a review of yesterday's losses and today's risk conditions. We need to separate daily noise from high-consequence risk and close the loop on actions before they become recurring agenda items. Weekly scheduled discipline is a reliability control. Once a maintenance schedule is frozen, breaking it should be treated as a serious business decision. This discipline is the only way to rebuild trust between the production and maintenance departments. On a monthly basis, we need a deep dive asset health review. This is the time to look at trends and bottleneck systems, evaluate if deferred work is still within risk boundaries, and engage finance to translate these technical risks into business value. This 18-month roadmap shows a path from diagnosis to scaling. We start by mapping current pressure points, then stabilize with protected windows, redesign our KPIs, and finally embed these behaviors into our CMMS and financial systems across the enterprise. In the first 30 days, the focus is on diagnosis. We need to map recent cases where pressure changed a decision and interview different departments to expose conflicting incentives. This builds the initial risk register for our most critical assets. From days 31 to 90, we stabilize the system by defining clear decision rights and protecting maintenance windows for critical assets. We introduce leading indicators to the dashboard so that risk accepted is tracked whenever a plan is changed. Over the rest of the first year, we embed these behaviors. We adjust scorecards, tie losses to owners, and integrate our data views. Most importantly, we audit whether decisions are actually changing, rewarding defect elimination rather than just heroic recoveries. Part 7 offers case vignettes and specific board actions. These scenarios can be used to test how your current management system would handle real-world trade-offs. In Vignette 1, a critical bearing defect is ignored to hit a monthly target. The result? A massive, unplanned outage that loses far more production than a planned stop would have. The lesson is that output without risk visibility converts controllable defects into forced outages. Vignette 2 shows how quality adjustments can hide deterioration. Operators tweak the process to stay on target, masking mechanical where that eventually leads to a bigger failure. We must remember that process instability is often an early warning for asset health. Vignette 3 demonstrates how simple cost control can backfire. Deferring routine work to stay under budget allows collateral damage to grow, eventually turning a small repair into a massive capital replacement project. Cutting maintenance costs can actually destroy enterprise value. Here is an exercise for your next board meeting. Ask which targets were achieved while risk increased, how many windows were canceled on bottleneck systems, and who exactly accepted the risk from major deferrals. The answers will tell you a lot about your organization's health. It's time to decide what to stop and what to start. Stop rewarding output without context and treating maintenance as optional. Start reviewing output and residual risk together and using risk-adjusted planning to protect your critical assets. Our final takeaways are these. Targets are necessary, but harmful if they ignore the asset system. Asset health is destroyed quietly through deferrals and local KPI pressure. The best industrial organizations don't choose between production and reliability. They make reliability the method by which production becomes repeatable. We conclude with a leadership commitment. We will hit our targets without hiding risk, protect maintenance windows as a core capability, and reward repeatable performance. This is how we build one operating system where every department wins together. Thank you for your time. This presentation was prepared for educational and professional discussion. For further information or to discuss these concepts in the context of your specific site, please feel free to reach out to me, Santosh Raikar.